In this video, we're going to talk about adding and subtracting rational expressions. And it's going to be similar to when you add and subtract fractions. So think about fractions for a second. If you had something like 5/7 and you were subtracting 1/7, first you need a common denominator for fractions to subtract them. So I need to make sure that if both of them are 7, then my denominator is going to stay as a 7. And then simply subtract or add whatever it's asking you to do, 5 minus 1, which in this case would be 4. If the denominators were not the same, something like 2/3 plus, 1/4, I would have to find a common denominator before I can add these. So for example, on this first fraction, I would multiply it by 4/4, and this one I would multiply it by 3/3, so that now that I have the common denominator, I am able to get an answer with the common denominator, okay? So same idea, obviously, just with rational expressions this time. So looking at how to add and subtract with like denominators, again, you're simply just going to add or subtract the numerators. This is as long as they have the same denominator. You're going to just keep the same common denominator in your answer. So this is the best case scenario. You won't have to do anything for the denominator. You just have to find what the sum or the subtraction is in the numerators. Now, when you're adding or subtracting with unlike denominators, you have to find a common denominator. And so we're going to rewrite each rational expression using the common denominator and then add or subtract. So first, if they don't have the same denominator, I have to find the least common denominator, least common multiple between both of them. So I'm going to factor each polynomial. We're going to write the factors as the products of primes. So just like we did for the previous section, we're going to go ahead and factor the numerator and denominator. And then I'm going to form the least common multiple by writing each factor to the highest power it occurs in either polynomial. And a lot of this will make more sense once we go into examples. You're going to be able to find this common denominator by multiplying the denominators together. So kind of like in my example here where we had to multiply by the opposite denominator to find that common denominator, we're going to do that again, but with rational expressions, okay? So going right into the first example, if I am adding and they have the same denominator, so note how the denominator for both of these fractions is x plus 1. That means that my denominator is going to stay the same for the bottom, okay? So I am going to just add straight across. So I have 2x plus 6x, and that gives me 8x. And then I have a -3 plus a 5, which is going to give me a +2. Now, we do want to go through and factor, just in case there's anything else that cancels out. You always want to simplify it if possible. For the numerator here, I can factor out a 2, leaving me with 4x plus 1 here inside the parentheses. And then my denominator is just x plus 1. In this case, I do not have anything that I can cancel out, but you always want to factor it out and see if that's the case. Okay, going on to example 2. So in this case, I do not have a common denominator for example 2. So again, your goal is to figure out how you can make that happen. This one, pretty simple, just like our fraction. So how can I possibly turn this 2 into a 4? I would want to multiply this by a 2. Now, when you're trying to change numbers in a fraction, you have to make sure that you're doing it to both the numerator and denominator. So that means that my numerator also needs to be multiplied by the 2. Now be careful here that you are, in fact, factoring this out to everything in that numerator for that fraction only. This fraction over here does not need to be modified, so nothing should be happening to those numbers. So in this case, I have x plus 9 over 4, which did not change at all. But then on the second fraction, I'm multiplying everything by 2, so I get 2x minus 6 over 4. Now that they have that common denominator of 4, I can combine like terms. So I have an x plus a 2x gives me a 3x. And then I have a 9 plus a minus 6 gives me a plus 3. Again, you want to go through and make sure you can factor it out in case you have anything in common that will cancel out. And in this case, my answer comes out to this. So no need to change that at all anymore. Okay, going on to number 3. So before I start number 3, whenever I see some sort of quadratic or any polynomial in general, I'm going to go ahead and factor it to see if I can figure out what it's missing. So when I look at this x squared minus 4, I know that that's a difference of squares. So if I were to factor that, it would be x plus 2, x minus 2. Okay, and then in the numerator, I have an 8. And then on this side, I just have x over x minus 2. Now, when you're finding the common denominator here, think about what is the other fraction missing. Here, I have an x minus 2 in common. So what would I need to add to this one, or multiply by, to have the exact same denominator? So the factor that this left one is missing is x plus 2. So I'm going to be multiplying the numerator and denominator times x plus 2. You have to remember, just like normal fractions, whatever you do to the top, you have to do to the bottom, and you have to multiply that through for both of them. So I'm not actually going to go through and multiply it out. I'm just going to combine these together. So in my denominator, I still just have x plus 2x minus 2. I'm going to leave it factored. And now this one's also going to have the same denominator. Okay, what I am going to do for this one, the numerator, is actually distribute it out. So I have x squared plus 2x, and then over here I have an 8. I can combine this to be one trinomial because now these numerators can be combined into one fraction now that I have a common denominator. So my common denominator stays the same, x plus 2x minus 2. Now my numerator is x squared plus 2x, and then the minus 8. Okay. When you're here, remember we keep having to factor, see if anything else cancels out or simplifies out. So when I factor the numerator, thinking about what two numbers multiply to a negative 8 but add up to a positive 2, I'm thinking x plus 4 and x minus 2. And then my denominator is still the same, plus 2 minus 2. And this is why it's important to go ahead and factor it out all the way through, because in case you have anything in common in the numerator and denominator, remember those can cancel out. So really, this simplifies to x plus 4, x plus 2. And this would be my most simplified answer. Okay, number 4. So number 4, it would help if I rearrange the way that the denominator is written here. If I rearrange this so that the x is first and then my number, so I would write this as a negative x because you bring the sign with you, and this is a positive 1. Looking at these denominators, so I haven't changed anything, I'm just rearranging it. What is the difference between these two? The only thing that's different here is their signs. This is a negative, this is a positive, this is a positive, this is a negative. So think about what you do to change the signs. I'm going to be changing the signs on the first one, and to do that, I'm going to multiply it by a negative 1. And then remember, whatever you do to the denominator, you have to do to the numerator. So my goal here, why I want to multiply by a negative 1 is because when I multiply, negative 1 times negative x, that's a positive x. Negative 1 times positive 1 is a negative 1. And then don't forget to multiply the negative 1 and the positive 2, giving you a negative 2. Now I can bring this down. Now I have a common denominator. So I, again, only needed to do one thing to one of the fractions. Given that I have one common denominator, I'm going to write it as one fraction. So that's a negative 2 plus x. Okay. If you like to write it, you may see this as a multiple choice option. Potentially, they will give you the x first, so you'll see it more as x minus 2, x minus 1. Can't really factor that out, so you are done with that one. Okay. All right, number 5. So now it starts looking a little bit more complicated, but same process. If you can factor anything out, factor it out, see if anything is missing, and then go from there. Okay, so here, again, I have a difference of squares, and this difference of squares would factor out to x plus 5, x minus 5. So that means that these fractions should have the same denominator. I need an x plus 5, x minus 5 on all of them. So what is each individual fraction missing? This fraction right here, it has the minus 5, so it's only missing the x plus 5. So this is missing x plus 5, x plus 5. This fraction here already has the plus 5, so it's missing the x minus 5. So I'm going to multiply both the numerator and denominator by the missing factor. Okay, so here's what I have. For this green one, I have an x plus 5 and an x minus 3 in the numerator, and my denominator is now x plus 5, x minus 5, plus this one, now I have an x plus 2, and then the x minus 5 that was missing. My denominator now is x plus 5, x minus 5, minus. And then the last one, I didn't have to do anything with because that's the one that had all the factors already, the x plus 5, x minus 5. Okay. So now I'm going to put these all together. Now that I have a common denominator, I know that they can all be over the same fraction, with the factors in the denominator being x plus 5, x minus 5. Now I'm going to go ahead and distribute all of my numerators. So starting with this one, I multiply it through, and I get x squared plus 2x minus 15. And then plus, so this is going to be positive. Again, multiply these out. You get x squared minus 3x minus 10. And then here's super important that this is all the quantity being subtracted. So you want to make sure you distribute that negative to everything, the 3x and the negative 8, making it a positive 8. Okay, then we're going to have all of that. We're going to combine like terms, see where we're at there. So combining like terms, I have an x squared and an x squared. That gives me a 2x squared. Then I have 2x minus 3x is 1x, minus 3x is 4x, negative 4x. Okay, and then I have the negative 15 minus 10. Negative 15 minus 10 is negative 25, plus 8 gives me a negative 17. Okay, and so you can try to factor out the numerator, see if anything cancels. In this case, it does not. So you are going to leave your answer as that. Okay. Same idea with number 6. You want to factor the denominator and again see which factor either of those fractions is missing. So for the last fraction here, which is the one that needs to be factored, this right here is going to factor out to x plus 7, x minus 4. So then look at each fraction and see what each one is missing. The first one is missing the x plus 7, so I have to make sure I'm multiplying both the numerator and denominator by x plus 7. The second one is missing the x minus 4, so I need to make sure that I'm multiplying the second one by x minus 4. Okay, so here we go. My first fraction just turns into x plus 7, x minus 5. And my denominator is this. Moving on to the second fraction, my numerator is this. And my denominator is now the common denominator for all three of them. Minus, and then again, remember, maybe adding those parentheses might help you. We're not changing anything on this third fraction, but remember that you need to distribute the negative through, so it might help to put parentheses there. And then x plus 7, x minus 4 is my common denominator. You are going to need to distribute these out, meaning that my new numerator for the blue one is x squared plus 2x minus 35. And then for the pink one, that's a plus, so I'm going to just say plus here, x squared minus x minus 12. And then the green one, remember, distribute that negative through, minus 4x minus 9. And all of that is over the common factor that we found of x plus 7, x minus 4. So I'm going to be combining like terms. I have an x squared here and here, giving me 2x squared. Then I have 2x minus 1x is 1x. Minus 4x is a minus 3x. And then I have negative 35 minus 9. Minus the 12 there. Gives me a negative 56. All over my common factor, x plus 7, x minus 4. And I try to factor it out, see if it simplifies. Otherwise, this is my answer. Okay. All right, last one here. So this is me combining the last section of dividing and also adding here. So we're going to follow our rules, skip, flip, multiply. But first, I should probably simplify this denominator right here. Okay, this denominator, I need to figure out how to get the same denominator. So essentially simplify that part before I can go into my division. Okay, so treating this as a new problem, just the denominator, I'm just going to rewrite it so we don't get confused. I'm focusing on this part first. Think about what each fraction is missing, and then we'll go right into the dividing in a second. So in order for me to get the same denominator here, I need to multiply this fraction by the opposite denominator, so that would be x minus 1. And remember, that's both to the numerator and denominator. And I would multiply this fraction here by 3, because I'm using the opposite denominator, and then going from there. So when I multiply this out, when I multiply these, I end up with x squared minus 1. And then in my denominator, I get the 3 times x minus 1 plus, when I multiply these two together, I get 12, and then 3x minus 1. Okay, so I can combine this as 1 now that I have my common denominator of 3x minus 1, and then going through, okay, so this is x squared minus 1. So we have a minus 1 here plus 12, which simplifies to 11, right? So it's x squared plus 11 over 3 times x minus 1. So essentially what I just did is I just rewrote this as one fraction so that I can go straight into the skip, flip, multiply. So I have this, and then my original problem has x minus 1 in the numerator. So following my rules, I'm going to skip, so do nothing with my first one. I'm going to write it down here, 1 over x minus 1. Then I'm going to flip. Remember, flipping it means that this is your new denominator, x squared plus 11. And then this is your new numerator, 3x minus 1. And then multiply, so these are being multiplied. So thinking about how you multiply fractions or radical expressions, so you would just combine them right into one big fraction. Looking here, don't forget your rules. If something matches, that means that they cancel out. So then I just see what's left in the numerator. 1 times 3 gives me 3. And in the denominator, I just have x squared plus 11. Can't factor anything else. Elsa, I can't simplify anything else, so I am done here.